Okay, it is 8 a.m. Monday morning, March 30th. Good morning, whoever happens to be awake. I've noticed I'm getting a lot more questions when people email me. It's always at like midnight or 2 a.m. So I'm sure y'all are taking this quarantine thing well. We can give people a few more minutes to kind of, slowly shamble their way into the chat. But plan for today is to lecture. So hopefully y'all got to see on the Google Classroom. We are doing a lecture today. Let's see. Also, y'all got graphs of cosecant, secant, and tangent and cotangent due today. So I'll post today's assignment as soon as we're done with this lecture, and I post the YouTube video and stuff. The only thing I don't have graded, I graded all of your makeup work and sine cosine 3. So the only thing I need to do now is grade your test. I'm not done with those yet, but they should be done pretty soon. I mean, I'd say probably today. Good morning. What, it's 8 a.m. Y'all haven't been awake 2 hours already like me? Okay, just another minute or two and then we'll start the lecture. I mean, I'm sure most of people, from what I'm seeing on my YouTube traffic page, most people are looking at this like in the mid-afternoon anyways, so we don't have to wait for everyone to be live. At 5 for no reason? 6 weeks, Omar, is over, I believe, after this week, right? We're still following the calendar that's on GCC ISD. I mean, we can just take a look right now. Calendars. And we are done after this week. Yeah, this is the last week of the 6 weeks. And honestly, after today's lecture, that's all we're doing in this class this week. So it's going to be set to be due April 3rd. And there is going to be an opportunity for extra credit on Friday. I'll post the rubric for what I want to do tomorrow, but basically we're just going to do like a, I'm going to do 2 of these. Oh, Alex, hi. Oh. There's another student with a similar username. I really should have just made y'all make usernames that I can just tell exactly what your name is, but that would make Twitch boring, right? So yeah, there's going to be an opportunity for extra credit. This week's is going to be really, really minor. I'm not going to actually make you do any kind of work whatsoever. Basically, you're going to find a group, and then you're going to do something on Zoom for me. So that's why I have the Zoom tab open. And then next 6 weeks at some point, because I'm assuming we're probably going to be doing this for the rest of the school year. Sometime afterwards we will actually put a project together, do like a presentation. You're going to screen share on Zoom, and you're going to have your peers actually review you. So, loosely related to math, but you can make it related to math however you want. Mostly just a chance for you to interact with your fellow students, because I know some of you, and I mean some of you are probably still talking to your friends and hanging out. But oh, Kevin, there is, and I haven't posted it yet. Let me actually just do that right now. Like, y'all get to see me do this. So I'm just going to head over to here. And I will add the PowerPoint. I don't know if I have to close it. Let's see. Oh, no, I guess I don't. Sorry, Kevin. I completely forgot about actually having it up. Because you're right, people have been writing on it and printing it and doing all that stuff. Okay, so it should be posted. Maybe you have to give it a few seconds, but it's there. And the relevant assignment I will post as soon as we are done with the lecture. Or I guess I can just attach it now. Doesn't hurt. Okay. Alright, so those of you live right now with us, you should be able to see everything that we're going to do for this week. So after the lecture today, then we're good to go. Okay, so before we do the pre-cal lecture, let me start talking about Zoom. We are going to be doing a group project at some point by the end of the week. So, I mean, for this week, it's probably not going to be a group project. I just want everyone to log in and make sure you can do Zoom. If you just Google Zoom or zoom.us, you can go directly. You do need to, I don't know if you have to make an account before, because the first time I used this, you can just click join a meeting, and then I'll post a meeting code whenever it's time to do it at the end of the week. And then I just need you to log into the meeting. You can do it on your phone. You can do it on a computer. If you have a computer, you're going to need a webcam on it, because, you know, on your cell phone, it'll just use your face cam. But the main purpose of me doing Zoom for a group meeting is so that everyone can be live simultaneously. Everyone can look at each other and hear each other. So really for this week, all I'm going to do is, hey, on Friday I'm going to start a Zoom meeting, and everybody that logs in will receive some form of extra credit. Whether it's going to be like a free daily grade, which is huge because daily grades are 80% of your average, or something similar. Okay? So details to come, but for now, if you haven't already been using this for another class, I don't know what your other teachers are doing. No teachers are talking to each other during this whole time, I don't think. But I'm going to be using Zoom. So I don't know, I was debating using Cisco WebEx, but there's no back and forth. Like, there's no, I mean, I can share stuff, but that's basically what I'm doing right now. Oh, the Zoom thing on Friday? Probably, I mean, it's going to have to be after office hours because I can't just do that while I'm streaming. WebEx? Yeah, I mean, WebEx works. There's nothing wrong with it. I just don't like that I can't do my whole, you know, webcam and screen share at the same time and you see the rest of the screen. Because you can do that on WebEx, but then nobody else can see anything. Also, I like my little overlays and stuff. Anyways, so that's it for Zoom. Just, you shouldn't need, you know, a lot of software. If you want to do it on your phone, you're going to need the app. You just look up Zoom app. It's easy. Okay, let's move on to the lecture portion of ours today. So, this is a lecture I really kind of hate doing online. I mean, not that I've ever done it before, but I just can imagine that I would hate doing this online, just because for regular pre-cal especially, this is going to be a very, very rough lecture for you. Other games besides Animal Crossing. I mean, I'm kind of on an Animal Crossing kick right now. Alright, see you later. I mean, I've been playing some League of Legends. I've been playing some Fortnite. I don't know. Either or. I'll stream some stuff. Also, I've just been playing games without streaming too, just because I didn't want to set up everything. Okay, so basic trigonometric identities. We are going to talk about this today. For pre-AP, this is about the level of work you expect. For regular, there's not really many ways to make this section any easier. So there is no regular level of this class, of this lecture, of this lesson. So we're going to do the best we can with it. Also, there's going to be a gigantic formula chart once you eventually get to doing the test. I mean, assuming you're taking the test at home, you won't need a formula chart. You can just look at your notes. But typically, when you do this test in class, there's a gigantic formula chart associated with it because you're going to be looking at and referring to a lot of formulas over and over again. So as far as things that you need to know currently, by the time we get to the test portion of this, there's going to be a lot of trigonometric identities. And what an identity is just another way of writing something. So, for instance, we all know that cosecant is equal to 1 over sine because that's the definition of cosecant. It's you take sine and you get the reciprocal. You flip it upside down. Well, that also works the other way around with sine and cosecant. And then similarly, secant and cosine, cotangent and tangent, they're all reciprocals of each other. And then for the quotient identities that you see right here, tangent is equal to opposite over adjacent in a triangle. So when you put that on the unit circle, it's equal to the y coordinate divided by the x coordinate, otherwise known as sine divided by cosine. So there's a few of these that you're going to use more often than any other ones. So I'm just going to mark them right now. So these 4 are used more often than the other ones. Not that you're never going to use the other ones, but with the strategy that I'm going to teach you to try to break things down as much as possible, these 4 are going to be what you refer to a lot. Because you see how there's 2 of them for tangent, right? There's tangent on the left, tangent on the right, cotangent on the left, cotangent on the right. But we want to use the form that has sine and cosine in it because that's going to be kind of our building blocks for simplifying things. And I know you're kind of wondering, why are we going to need these? You'll see the types of problems we're going to do by the time we get to a few slides from now. Okay. All right. And then this, I put a little star on here because you're going to be using these a lot. All of you pre-AP kids that are going to be doing calculus after this, you're going to be using these a lot in your trigonometry parts of the problems in class. But, even more so just for right now because you're going to be doing this work this week. So, we can talk about the derivation of this, but I'll just do kind of a quick one because regular doesn't care and pre-AP you might slightly care. If you think about a unit circle, and then you just pick any random point. It doesn't even have to be one of those special angles on your unit circle. But if you look at it, it has an x-coordinate point and a y-coordinate point. We know that we draw this little triangle, and we have the angle stuff that we did before. The hypotenuse is 1 because the radius of the unit circle is 1. And the adjacent side is cosine, and the opposite side is sine. So if you just do Pythagorean Theorem with that triangle we've created in the unit circle, Pythagorean Theorem states that sine squared plus cosine squared equals 1 squared, which is just 1. So that's why we call it a Pythagorean identity. All of the other 8 that you see on this page are just derived from that very first one. Sine squared plus cosine squared equals 1. And honestly, that one, if you want to go ahead and start it too, it's going to be the one that you use the most often out of all 9 of these. So as we move on to different problems, what you're going to see is that we're going to have a complicated looking expression. It's going to have a bunch of things on it, some things added, fractions together, whatever. And then we're going to use some combination of these identities to break it down as small as possible to make it reach the end goal. So here's what I mean by that. The weird thing about these problems, and it's going to screw up a lot of people whenever you first work on it, is that I'm going to be giving you the answer before you even begin the problem. So if you take a look at this one, if you're multiplying and dividing fractions, the left-hand side of the equation is what we're starting with. We want to do a bunch of math to it to simplify it as much as possible, and by the time you're done, you should reach the right side of the equation. So this right here is your answer. You are already being given the answer to the problem. So when you eventually take this test, or whenever you do this homework, the only thing that gets graded is your work, which is going to bother some of you because, you know, some of you don't show nearly as much work as others. Okay. So whenever you have a problem, there's going to be different approaches of algebra that you want to use to get from beginning to end. So I've tried to break it down as much as possible into all these different slides. So my goal by the end of this lecture is that as you do your homework, you should be able to just have this PowerPoint open, look at each of these, and then hopefully find one that looks like, you know, like a layout, like a skeleton for following with your problem. The annoying part about these worksheets and about this test in general is that every single problem is going to be unique, in the sense that it's not just changing numbers because we don't have numbers, right? Every problem is going to require a different type of work. Also, there's going to be multiple correct ways to get the answer. You can have two students do two completely different things, and they'll both get full credit. So that's what bothers some students with this unit. Okay, so if we look back at a couple of slides ago, one of your main strategies for simplifying things as much as possible, if you don't see any sort of easy algebra to do at the beginning of the problem, what you want to do is rewrite things in terms of either sine or cosine. So if you see something in your problem that is not currently the sine or cosine function, rewrite it using one of these starred identities to make it sine or cosine. So for this first one, the left-hand side, my problem portion of the problem, says cosecant times cosine times tangent times sine. Well, I can rewrite cosecant as 1 divided by sine, because that's what it says back here, right? That first starter one I made. That's being multiplied to cosine, which, remember, is a fraction. It's divided by 1. The cosine's in the numerator this time. Tangent is sine divided by cosine, and I'll let you flip back yourself for that one. And then sine just by itself, and it's a fraction on top. So notice how all 4 of these are being multiplied to each other. So if you have fractions being multiplied, if you ever have anything the same on top and bottom, you can cancel them out, right? Because we know we can do that with fractions. So with all 4 of these side by side, and they're all rewritten as sine or cosine, now you see some things cancel, because this bottom sign cancels out one of those top signs. This top cosine cancels out that bottom cosine, and after all the canceling is done, the only thing left over is a single sign, and that's equal to what the problem said should be left over at the end. So again, it's going to be weird for some students because you're already given the answer. So you know where the problem should end up by the time everything is done. It's just, if you want, let's pretend this were a test question. If you want full credit on this, I have to see all your work. Now this one is the easiest problem you're going to have because there's only one line of work. But as we do more and more, you're going to have some that have 4, 5, 6 lines of work, and you're going to need to show most, if not all of it, depending on how comfortable you are with math. Don't feel like you're going to bother me too much if you skip a couple of easy algebra, like we're going to be dividing and adding fractions later. If you are comfortable enough with common denominators and shoving everything together that way, you're not going to lose me whenever I'm grading. But if you just... Here's what some regular pre-cal students do. They have the problem, pretend I don't have any writing on here, and they'll say, hey, wait a minute, here's the answer. Oh no, I just did it all in my head, mister. I know how to do all this. And you can make that argument for every single problem in this entire test because you're going to be given the answer on every single one. So that's not good enough. Even those of you that are very, very good at math, some of you might be better than me at math, but you have to show your work. Okay. All right, anyways, I'm going to erase this little blue box. People at home are going to be wondering what the heck it is. All right, next type of algebra that happens is distributing. One of the key things for this one, whenever you think you might need this, is if you see something outside of a parentheses, if you see something that looks like it could be distributed out and multiplied to create new things. So here we've got cosecant times cosine plus sine. We're going to distribute, because if you have something on the outside of a parentheses, you can distribute it just like we would have with numbers and x way back in algebra class. So we're going to write cosecant times cosine plus cosecant times sine. And now this cosecant can be rewritten as 1 divided by sine. Alex, you'd be surprised at what I deal with on a daily basis. Okay. So I just rewrote both cosecants as 1 divided by sine. Remember that cosine and sine that were already there, you're going to be dealing with this a lot in this unit, is that things that aren't currently fractions can always become fractions if you put a 1 on the bottom, because these are two fractions being multiplied together. Now on the left, you have 1 over sine times cosine over 1. Nothing cancels here, so you can go ahead and multiply these together. But on the right side, you have 1 over sine times sine over 1. Those sines do cancel, and all you have left is 1. So you've got cosine over sine plus 1. And cosine over sine, if you flip back, is an identity for cotangent, that last star that I made on the right column. So we can actually just use an identity to rewrite this as cotangent. And that is the end of the problem. That's what we wanted. That's the answer. So I am boxing the solution. You don't really need to, because I already know what the solution's supposed to be. If you, I don't know, what I was taught in college is that at the end of a proof, because these are proof problems, by the way, if you just put little diagonal lines like that at the end of the problem, that signifies that you're done with a proof. And you can do that. That's what I taught my college classes. You can do that instead. Okay, next type of math that can come out is factoring, the exact opposite of distributing. If you ever see things being added or subtracted and those different things all have a term that's the same, so if you look on this problem, there's a cosine minus cosine times sine squared. Both of those have a cosine in them. So I can do the opposite of what I did earlier. I can factor cosine away from both of those terms. And I'm left with 1 minus sine squared. And here's where one of those, that second page of identities comes into play. If you ever see anything being squared and or the number 1, these are your hints that you should look for Pythagorean identities. So I see 1 minus sine squared. If you flip back here, 1 minus sine squared is equal to cosine squared. It's the very second one on my page. It's the one underneath the star. Here, let me use my mouse cursor. Oh wait, I have a little highlighter. Or a laser pointer. This one. Right there. Oh look, I found a use for the laser pointer because I'm not actually in front of you anymore. So I'm using that one. So let's go back to our problem. 1 minus sine squared can just be replaced with cosine squared. Yeah, I mean, I understand it doesn't seem too hard. It's a little bit tedious. it's not like the difficulty in the problem comes from the individual problems being ridiculous. I mean, we're going to have one later you're not going to like. But the difficulty comes in the fact that every single time you see a new problem, it's going to be something where you have to think of something new. There's not just like a specific template for, oh, this is this type of problem. If I just move this number this way, I get the answer. You just constantly have to think about, 6 or 7 different options you can take at the beginning of the problem. And it's just, mentally taxing, I guess. I don't know any other way to put it. But by the time we get to this exam, you'll see, because we'll be taking this exam, with the pace that we're doing right now, probably in about 2.5 weeks, because I don't want to push anything. Assuming we're doing this to the end of the school year, we're going to slow down a lot. Normally we do 2 to 3 lessons a week, where I'm not doing any more than 1 a week. So, okay, anyways, end of the problem. Cosine times cosine squared, they're both the same thing, just like you would have x times x squared be x cubed. Cosine times cosine squared is cosine cubed. And that's my answer. Okay, Pythagorean identities. Oh, I talked about this earlier, where you have the number 1 and you see something squared, or you see 2 things being squared. That should be a really big hint that you should look for Pythagorean identities. Sometimes the problem will trick you and you can just do it immediately at the beginning of the problem. Because you see on the denominator here, you have tangent squared plus 1. If you flip back here, tangent squared plus 1 is this one right here. It's immediately already a Pythagorean identity. So tangent squared plus 1 becomes secant squared. So let's flip back to our problem. My first problem will be substitution. There we go. So we did a Pythagorean identity substitution just to start the problem. And then now somehow tangent squared divided by secant squared should turn into sine squared. If at some point now you get lost, the one thing you don't want to do is go backwards and try to replace tangent squared. Because if you look at this one right here, technically tangent squared is secant squared minus 1. You never really want to substitute in a way that adds more things, right? If I did that substitution, it would take something that's one term, the tangent squared, and it would break it up into 2 things, which would be secant squared minus 1. That's not the goal of this. You want to make things as small as possible. You want to cancel things. You want to take 2 things and turn it into 1 thing. So condense things as much as possible. If you get to this point and you don't know what to do, go back to your basic foundation, your building block of this, which should just be rewrite everything as sine or cosine. Because tangent squared is sine over cosine squared, because back here tangent is sine over cosine. I'm just squaring the whole thing. So I've got a fraction divided by a fraction. I've got sine squared over cosine squared. That was your old tangent squared divided by, and secant squared is going to be 1 divided by cosine squared. Not every time one specific thing is squared, what you want to look for is some combination of the number 1 and something squared, or 2 different things being squared. So let me pause on this problem to go back to this page. So out of all 9 of these that you see, they're all some combination, because there's 3 things in each of them, right? There's some combination of the number 1 and 2 things being squared, whether they're being added or subtracted, and you have to just kind of look at the problem to figure out which. You always want to substitute in the direction that takes 2 things and turns it into 1 thing. So for example, over here, if I see 1 plus cotangent squared, I could replace it with cosecant squared. I don't ever want to go the other way around where I have cosecant and I replace it with 1 plus cotangent, because that's just adding more things to your problem. Usually the goal of these problems is to simplify and make it smaller. So I could happily replace cosecant squared minus cotangent squared with the number 1. Or 1 minus sine squared with cosine squared, for example. So look out for more than just something being squared, I guess. Thank you for the question. Ah, there we go. Okay, so moving on this problem, I have a fraction divided by a fraction, so we're going to keep the first one, flip the second one, and multiply. So for my next line of work, I've got sine squared over cosine squared times cosine squared over 1. And the cosine squareds cancel. So all you have left is sine squared, which is what I wanted. Sure, no problem. Okay, this is the last one. It's going to be the most annoying one. I don't think regular ever has to deal with this one. I'm not sure. Please don't quote me on that one. This very easily could show up on either version of the test. But this is going to be kind of a long problem. I'm going to start it way over on the left. So you have cosine over 1 plus sine plus 1 plus sine over cosine. They're just reciprocals of each other, right? But the only problem is that when you try to add them together, you need a common denominator to add fractions. Also, I don't have any Pythagorean identities because they don't have anything squared. And I can't rewrite things as cosine and sine because guess what? In this problem, everything is already cosine and sine. There's no substitution to make. So the only way to begin this problem is try to add these fractions together. So I need a common denominator. So my common denominator in this problem is 1 plus sine. So here, least common denominator. It's going to be 1 plus sine times cosine. Because the only thing you're allowed to do is multiply. So on the left fraction, I need to multiply it by the other denominator to make them the same. So we're going to multiply it by cosine over cosine. The right fraction needs a 1 plus sine over 1 plus sine. And I'm writing all over the answer here. So I've got to rewrite both of these fractions. So on the left side, it's cosine squared over cosine 1 plus sine. So I've rewritten the left fraction now because the cosine multiplies to the top and bottom. Plus, and then now I have 1 plus sine times 1 plus sine. And now I have the same denominator over here. So great, I have the same denominator on both. I can go ahead and add them together. So I have cosine squared plus, and then let's go ahead and FOIL this. So I've got to distribute this. So I've got 1 plus sine plus sine squared, all divided by, and then I still have this cosine. And we could distribute the cosine. I'm going to leave it alone because you're going to have to factor it out again later in the problem to cancel some stuff. Alright, so it's looking like a bit of a mess. I think I'm probably just going to stick in a new blank slide here to finish the problem. But the key thing to the next step of work in this one is I have a cosine squared and I have a sine squared. And way back here, this starred one I have at the very beginning, sine squared plus cosine squared in either order, remember addition you can move around, is equal to 1. So both of these cancel out to just become the number 1. So now my new numerator is just 1 plus sine plus sine. Those are the only things in the numerator. So let me make a new blank here. Let's finish the problem. So my numerator now, all that's left is 2 plus 2 sine. Still have the same denominator. I haven't messed with it at all this whole time. The numerator now has a common factor of 2, so I can factor like I did a few slides ago. make parentheses, factor the 2 away, because when I do that, check it out. What do you know? I've got a 1 plus sign on the top and bottom, which I can now cancel. So all I have left is 2 divided by cosine, which is the same thing as 2 times 1 over cosine. And 1 over cosine is secant. So I would say by far that's the longest. That took, what, 4 or 5 lines of work. This would be the longest problem you would have to do. But depending on how the beginning of the problem goes, it may take 1 less line, it may take 1 more line. You can't really skip any of this because, remember, your work is the only thing being graded. But the tricks here were that you had 2 fractions that either had to add or subtract, and that requires common denominators. So it's going to be messy. These are going to be the messiest problems when you see fractions being added. But all of your problems are going to be some variation of these algebra things. So I think if you just have this open as you're doing your work, it should help out a lot. And then these will be on a formula chart when we eventually take this next test. Okay? All right, so let me look for questions in the chat. Anyone have any questions? Okay, the last thing I want to talk about is on the Google Classroom. So pre-cal, I'm assuming y'all are the only ones hanging out right now. Pre-cal, I posted today's stuff. I'm going to make a classwork tab here in about like 3 minutes. I'm going to post your assignment. You can do your uploading and writing and turning in just like normal. The one thing I want to point your attention to, especially regular, is exam number 1 right here. So what I did, I tried to post on the stream about what I did with your grade. So since all the categories changed and we're not allowed to mess with what's where, in terms of, what percentages go where, I've replaced all of your assignments that you did for me before spring break. What I did is I replaced all of those grades with what your progress report grade was. I know that's not accurate for all of you. In fact, for half of you, it's not accurate because you were absent for a day that you were supposed to turn something in, or you never took test number 1, or you did take test number 1 and you never had a chance for a retest, things like that. A lot of people are being affected by it. So what I decided to do, just kind of as a blanket here, this should fix everyone. If you are currently failing the class, I posted a version of test 1. Okay. It's exactly like test number 1, all the same structure, everything. I even replaced the unit circle with a filled in unit circle at the end so you wouldn't have to fill it in yourself. But it's basically the same test again. I want you to work the whole thing just like you did for exam 2. I will grade it, and I will fix your pre-spring break grade. I will fix your progress report grade. So all that big row of 7 grades that are all the same, they will all get fixed with what it's supposed to be. And because I have all your old average, and then I'm just going to re-average your pre-spring break grade with this in it. So this should fix everyone's grade that is currently failing. Okay, notice how some people did it already. I do have this due this Friday, April 3rd, because I do need to have your grades done by Friday. So if you are in that boat, please get that done. And I will make this tab for today's assignment here in a few minutes. Okay. Are there any questions? Okay, I'm not seeing any right now, so I am going to cut off the video portion of the stream today. And those of you watching on YouTube, I will see y'all tomorrow morning or whenever you open this video.